Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is count subarrays where max element appears at least k times. Okay, so you will be given an integer array nums, and a positive integer k will also be given to you. There will be a maximum element in this particular array nums, and you have to count all the subarrays in which this maximum element appears at least k times. Okay, so and those of you who do not know what a subarray is nothing but a contiguous part of an array. Okay, subarray is contiguous sequence of elements within an array. So let's say this is the array that is given to you. Okay, these are some elements, so this can be a subarray, this also can be a subarray. Okay, but this cannot be a subarray. I mean, you are missing this part in between. Okay, so it should be contiguous. Okay, the sequence of elements that you are choosing should be contiguous. So that is what a subarray is. Let's have a look at the constraints before solving this or thinking of an approach to solve this. The range of num's length is of order 10 raised to power 5, and each element is ranging from 1 to 10 raised to power 6, and k will be ranging from 1 to 10 raised to power 5. Okay, so let's see how we can solve this particular problem. We will try to solve it in the most optimal way possible. So let's take one of these examples. Let's take this one. Okay, so this is the array given to you. Let's mark the indices first. 0, 1, 2, 3 and 4. Okay, so what is the maximum element? It is 3. Okay, so now how we will find out the subarrays? What we can do is we can sort of have a two pointer like approach. You know what I mean by two pointer like approach? You will be having 2 pointers left and right. This is let this be your left pointer, and let this be your right pointer. Okay, right pointer will be used to increase the window size. What window? Window between left and right. Right now left and right are at the same point, so there is window of 0 size. Okay, so there is no window. If let's say left is here and right is little bit here, so this is a window in between left and right. Okay, these are the set of elements between left and right, so it is itself is a subarray. Okay, if you take all the elements between left and right, it will be a subarray, or you can call it a window also. Okay, so what we'll be doing is we will be moving right towards right. Okay, we will be traversing the array in this fashion. Left will, for now, I will tell you what is the role of left here. First of all, right will be used to increase the window size, and let's take another variable, max element count. Max element is initially 0 since we are at 1 and it is not the max element. Then right will proceed further, it will be at this number which is maximum element, so maximum element count will be updated. It will now become 1. Okay, so now moving further, right will be at 2, which is not maximum element. Now moving further, right will be at 3 again, which is by the way maximum element, so this will again be updated. Okay, so this comes to 2, Then again moving further, now 2 will also be updated to 3. Okay, but we will before moving further, what we will do, once we once your maximum element count becomes equal to k or greater than k, what you will do, once it become equal to k, you will start decreasing your window size from with the help of left pointer. What I mean by this is, right now situation is like this: 1 3 2 and then 3 and then 3. It is the window array that is given to you, and your left one is here and right is right now at this particular point. Okay, so what you will be doing is, you will now here at this point your max element count is 2, which is equal to k. So you will decrease your window size. Okay, decreasing it means that you will be moving left pointer towards right pointer. Okay, or you can say in right direction. So as you move this left pointer towards right, you will see that this window size is decreasing, the size of window between left and right. So left will be here. Okay, once left is at a point at a number that is equal to maximum element, you will decrease maximum element. It will now become equal to 1. Okay, and left will move further. So at this particular point, what you will be having is, let's mark the indices. Let's change some color here: 1 0 2 3 and 4. So right now your left will be at 2, maximum element count is 1. So as soon as maximum element count drops below k, you will stop then and there only, and you will see that if you carefully observe, when you were at this particular position and your left was at 0, how many subarrays could have been formed which will be having at least k repetitions of maximum element? Those subarrays could have been, in this particular case, when left was here and your right was here, so it would have been 3 2 and then 3. Okay, it would have been one of these arrays, and if you ignore this particular one, then it would also have been 3 2 3. Okay, so these two. Okay, you are getting the point. So these two elements contributed in subarrays, two different subarrays. Okay, now as soon as left is at a point where maximum element count is below k, you will see what is the value of the index at which left is at. Okay, so it is at 2. It means that 2 entries have already been passed on this left hand side. Okay, so it means that those entries could have contributed to what? Could have contributed to subarrays. Okay, so those two entries I am talking about. Okay, so what you will be having another variable. Let's call this subarray count. Okay, you will add the value of left, current value of left, to subarray count. Okay, those number of subarrays will be added. So these two entries would have contributed to the subarray that we are wanting, where maximum element is appearing at least k times. So right now subarray count will be nothing but 2. Now moving further, right will move here. Okay, left, for the sake of clarity, left is no longer pointing here, it is pointing this direction. Let me clearly show it. Okay, and right will move here, it will be shifting from here. As soon as right move here, you will see that it is at a maximum element, and your maximum element count will increase from 1 to 2. Okay, now you will see that maximum element is again equal to k, so we should drop it below k by shrinking the window size. So left should be moved towards right. Okay, so you will do that. and when you will move left here, okay, so the situation right now is this. Let me erase some part. Okay, so left is here, right is here. Okay, and max element count is 2, so you should drop it below k. So shrinking window size by moving left. So as soon as left reaches this third index, you will see that it is having maximum element, so you will decrease maximum element count to 1 again, and at this point you will stop because maximum element count have dropped below k. Okay, so you will see what is the index at which left is at. Okay, so left is at right now the third index. Okay, so the third index is the index at which left is at, and I mean it will be not at the third index where you will stop, it will be at the fourth index. Okay, a little bit of mistake from my side. As soon as you reach 3, you will decrement the count, and then left will be stopping when it reaches the very next index, which is the fourth index. Okay, so the situation becomes like this when you will be stopping and your maximum element count will be dropping below k. So this will be your left. So what is the index? Fourth. So how many entries could have been contributed to 4 entries? How so? 1, 3, 2, and then 3, and then 3. It could have been one. Okay, one of those entries. Another could have been, if you ignore 1, 3, 2, 3, 3. Okay, if you ignore this one also, then 2, 3, 3. If you ignore this one also, then 3, 3. Okay, you see that there are 4 entries that could have been contributed. So these 4 I am talking about. Okay, so now you get the idea how things are working out here. So simply adding 2 plus 4 is equal to 6. So 6 subarrays will be there in total, in which maximum element, which is by the way 3, is occurring at least k number of times. Okay, so this is the whole logic and how things will be working out. Let's see the implementation. Okay, it is a C++ code, so we should be moving it here, and this will never be greater than k. We will not allow it to do so, so it should be equal to k only. Okay, so initializing left and right at the 0th index, this is just a variable to store the size of the array. Then you will see what is the maximum element in the whole array. Okay, once we are getting hold of that element, we will start the counting. This is the maximum element count. Okay, you can rename it also maximum element count. Okay, and yeah, we will do so till your right pointer reaches to the very end. Okay, if there is the number that is present at the right index pointed by the right pointer is maximum element, in that case you will increase maximum element count, and till your maximum element count is equal to 0 and it does not drops below it, you will keep incrementing your left pointer, and if left pointer is at a value which is equal to the maximum element, then you will simply decrease the maximum element count, and as when this maximum element count drops below k, you will directly know how many subarrays could have contributed. Okay, previous indices could have contributed to how many subarrays. Okay, what we are doing is essentially we are just fixing our right. Okay, fixing right at a particular point, and let's say this is left here, and then we are moving left towards right and shrinking this window size. Okay, so this window size keeps shrinking, okay, like this. And as soon as the value of maximum element count, this one, drops below k, you will stop then and there only. So, and you will be knowing that how many entries passed. Okay, so that's why these things works out here. I hope you are able to understand. And then simply you will be returning subarray count. Okay, that's pretty straightforward then. And let's try to submit once, see whether the changes that we made are not giving any error or something. Okay, it's getting accepted. Okay, so this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead. And before ending the video, I would also like to mention time and space complexities. Time and space complexity wise, it is for time complexity, as far as it is concerned, it is order of n, where n is the size of nums array. Okay, and space complexity wise, it is nothing but order of 1, since we are using constant extra space, just playing with some pointers, doing nothing more than that. Okay, and yeah, this function also, maximum element, it is also order of n. I mean, you are just traversing the array only once and you are just finding out what is the maximum element. Okay, or else if you want, we can check its time complexity also. I think it should be that. Okay, it's order of n. So yeah, order of n, time complexity, and constant extra space. So thanks again. Bye bye.